In this lesson, we're going to discuss rootkits. Now, a rootkit is a specific type of software that's designed to gain administrative level control over a given computer system without being detected. Now, this is a really important concept because if somebody can install a rootkit on your system, they can gain root or administrative level permissions over that system. And this is the highest level of permissions that somebody can have on a given computer system or server. So, if you're using a Windows machine, for example, the account with the highest level of permission is called the administrator account. That administrator account allows the person to install programs, delete programs, open ports, shut ports, and do pretty much whatever it is they want to do on that given system. If the victim is using Unix, Linux, or a Mac OS computer, this type of administrator account is actually called the root account. Either way, gaining administrative or root account access is a wonderful thing for an attacker or threat actor, but it is a horrible thing for you and the security of your system. So now that you have an understanding of what a rootkit is and the type of permissions it's seeking to gain, let's take a moment to learn how a rootkit actually works. Now, if you look at a computer system, it has several different rings of permission used throughout the system. The outermost ring is called ring 3, and this is where the user permissions are going to be used. So if you're logged in as a standard or regular user, you're mostly going to be operating in ring 3. Now, each program can be run in different security rings, moving from ring 3 at the outermost level all the way down to ring 0 at the innermost or highest permission level in the system. When you're operating in ring 0, we call this the kernel mode. The kernel mode allows the system to control access to things like device drivers, your sound card, your video display or monitor, and other things like that. Kernel mode, or ring 0, is not something you're going to log into the system as, but instead it is the most trusted and powerful ring inside the operating system's design. Now, if you log in as the administrator or root user on a system, you're going to have root permission, and you'll be operating at ring 1 of the operating system. Now, this is closer to ring 0 than ring 3 was, so it's easier to do more damage on the system from ring 1 than it would be from ring 3. Now, when a rootkit is installed, it tries to gain the highest levels of permission possible. So any malicious code it's going to execute will operate in ring 1 or, if they're lucky, even as low as ring 0. Remember, the closer the malicious code is to ring 0 or the kernel, the more permissions it's going to have and the more damage it can do on your system. Now, when a rootkit is installed on a system, it tries to move itself from ring 1 to ring 0 so it can hide from other functions of your operating system as well to avoid detection. In fact, rootkits are able to perform malicious operations on a target computer at any date they want without the knowledge of the administrators or the users, and even sometimes without the knowledge of the operating system itself if they're properly coded. Remember, a rootkit is designed to really dig into your operating system deeply so your antivirus and anti-malware solutions have a really hard time detecting them. Now, one technique that's used by rootkits to gain this deeper level of access is known as a DLL injection. Now, a DLL injection is a technique used to run arbitrary code within the address space of another process by forcing it to load a dynamic link library. A dynamic link library, also known as a DLL, is simply a collection of code and data that can be used by multiple programs simultaneously to allow for code reuse and modularization in software development, and these DLLs are often provided by default inside of the Windows operating system. With a DLL injection, the malicious code is going to be inserted into a running process on a Windows machine by taking advantage of those dynamic link libraries that are being loaded up at runtime. This means that the Windows system doesn't even understand the fact that it has a rootkit installed inside of one of those DLLs that it's then designed to load every time you boot up a Windows machine. This kind of DLL injection is going to work by using what is known as a shim. Now, a shim is simply a piece of software code that's placed between two components, and it intercepts the calls between those two components, and then it can redirect those calls. So the rootkit will intercept the communications between the Windows operating system and the dynamic link library, and then it redirects that call once it's embedded into some kind of malicious code that's being embedded inside of it. Now, these rootkits are extremely powerful, and they're also very difficult to detect because the operating system is essentially blinded to them. To detect them, the best way is to boot from an external device and then scan the internal hard disk drive or solid-state device to ensure you can detect those rootkits using a good anti-malware scanning solution from a live boot Linux distribution. So remember, a rootkit is a piece of malicious software that's designed to infiltrate a computer system at the highest administrative permission level while remaining undetected. Rootkits aim to gain access as close to ring 0 as possible, and they'll start out at ring 3, the user level permission ring, and work their way down all the way to ring 0, the kernel mode permission ring, where they can wreak the most havoc. A rootkit's primary objective is to seamlessly embed itself into the operating system, and this is often done by exploiting the system's inherent trust in the dynamic link library system, or DLL system, using a DLL injection and the use of a shim technique. Because of the deep-rooted nature of a rootkit and its ability to hide itself from the operating system, traditional antivirus and anti-malware solutions will often fail to detect rootkits. Therefore, the most effective method for rootkit detection and removal is going to be to conduct an external system scan. Remember, guarding yourself against rootkits does require continuous vigilance and the implementation of robust security measures across your entire enterprise systems.